Hello fellow roboticians, welcome back to another amazing video by yours truly. Without wasting any more time, let's get right in. This year, there are 4 blocks with 6 slots, while 2 are left blank, which yields 360 possible combinations. But of course, we aren't gonna make 360 different programs because we have a much more elegant solution.
Green, no, yellow, white, red, no. Yellow, no, green, white, no, red. Yellow, green, no, red, white.
Oh, wouldn't doubt.
Now let's see what's the code behind it. First, let's do the classic initialization of our movement blocks. Then we will broadcast a message. A message is really useful to do simultaneous actions in spike word blocks. The message contains the color checking code. The program will basically work like this. In one branch, the robot will drive forward for 85 centimeters, which is the whole distance used for the color checking. It uses a simple proportional yaw control to keep the robot heading straight for consistent color reading. In another branch, there's a color reading code. Here, before we do anything, we create 2 lists. The first list is a multi-purpose list. That's the heart of everything. I'll call it scanning. It has 6 indexes and starts with the numbers 24, 33.5, 43, and so on, up to 71.5. These aren't just random numbers, but they're distances in centimeters, which tells the robot exactly when to check the color sensor as it moves forward. And the second list is a list used for a median filter. This is because our robot will detect the block 3 times and use the median value as the output. This way, we make sure that our color detection is free from any reading errors. Next, we have a loop. The loop repeats 6 times, which is the length of the scanning list. In each loop iteration, we wait for the motors to reach the degree target that we put in the scanning list. For example, the robot needs to move 24 centimeters or more in order to scan the first block, 33.5 for the second, and so on. Then the color sensor will read the color values 3 times, and it will do a bubble sort algorithm to sort the information in ascending order. Then it will extract the median value as the output and determine what color it is. Since Spike app doesn't have a list sorting function, we need to make our own bubble sort algorithm. Here's how. We have one loop nested into another loop to avoid rechecking sorted elements at the end. It will compare adjacent elements in the list, and if an element of a list is larger than the value in the next one, it will swap places. After the sorting, it will put the median value in the scanning list as the output, replacing the original degree value. Lastly, it will replace the value in the scanning list with the name of the corresponding color and play the sound of the color to signify the scanning. Remember that all this is done simultaneously with the wheel constantly moving forward. It doesn't stop to read the blocks, which saves a lot of time and makes a more reliable run. The full downloadable code is in a Google Drive link in the description. Feel free to check it out at all times. Thank you for watching.